And basically what we did in the last lesson, we established that if we've got some function f, right, and we take a kind of an initial guess, then what this formula does is it generates a kind of a next guess. So in other words, if that's x naught, it works out where that tangent will hit the x-axis and it treats that as x1. And then we put x1 in and we get x2. Right. So now we're going to do a specific example and the whole thing will make a whole lot more sense. Right. So we're going to try and solve this equation. X cubed minus x minus 1 equals naught. We're always trying to solve equations of the form f of x equals naught. In other words, we must have a 0 on the right-hand side. Okay. If you look at the formula here, which you get provided in tests and exams, we're going to need the derivative of f. So our function here is x cubed minus x minus 1. What will the derivative be? Very easy. 3x squared minus 1, okay? So for this particular question, okay, our recursive, it's called a recursive formula, is as follows, okay? What we're going to do is we're going to work out xn plus 1 by taking xn minus our function evaluated at xn, which means we're going to put xn into the function. I'm talking about this top piece here. So it's going to be xn cubed minus xn minus 1. And on the bottom, we're going to have the derivative evaluated at xn. So in other words, it's going to be 3xn squared minus 1. Okay, so just to highlight this piece here is this piece here. It's the function evaluated at xn, right? And this piece here is this piece here. Okay, and what the question says is start off with x naught equal to 5. Okay, so x naught is 5. So what I do now is I put 5, this is so annoying, I loaded it, I had my calculator already loaded. I had to restart my PC. Okay, so what I'm going to do is I'm going to put 5 in to this formula here. So 5 minus fraction, all right, 5 cubed minus 5 minus 1 over 3 lots of 5 squared minus 1. Okay, and I get 3,392 approximately. 3,392. So x1 is 3,392. Okay, because I've put x, picture if n was naught, then all these are x naughts, and here I've got x1. Okay, now what I'm going to do next is I'm going to put this number in where all these xn's are, and I'll get to get x2. No, so I'm going to show you, there's a very cool, clever trick that your calculator does. Okay, so but let me just quickly show you a visualization of this, okay? And again, really irritating because I teed all these things up to show you before the lesson and before I had to restart my machine. And so now I'm scrambling and I'm looking for files, but it's worth finding this file to show you because it will sense of the whole thing. Okay, so what I've got over here is a little simulation of all of this. Okay, I'm going to change my function here to x cubed minus x minus 1, which is the function we're dealing with. Okay, now, and I'm going to zoom out a little bit on the y, and in fact quite a lot, and I'm also going to move my x naught to 5. Okay, and I'm going to try and zoom out a little bit on the x as well. So I can zoom out on the y. Okay. I'm going to do that. Okay, right. So guys, what I'm going to do is I'm going to do the first iteration. In other words, I'm going to go up from here to where the curve is, and I'm going to draw in the tangent, and there it is, okay? And what you'll see is that there's x1 on the left-hand side. There's 3,39189, okay? So that's the next guess, okay? Now what I want to do is I want to put that number into this formula, okay? But watch what I'm going to do now. This is very clever, okay? When you press equals on your calculator, the calculator stores that number into a memory called answer. And you guys know this. So if you go answer equals, there it is, it's 5. Okay, so now what I'm going to do is I'm going to type this thing in, but instead of xn's, I'm going to use answer. So, correct. So I'm going to go answer minus answer. I've got 5. I put 5 in, yeah. I put 5 in. I'm just going to show you that we're going to get that first one. Okay, minus answer minus 1 over 3 lots of answer squared minus 1. So in answer at the moment is 5. When I press equals, the calculator will calculate that. It should give me 3,3918 whatever. Okay, there it is. It's actually 251 over 74. There it is there. Okay. And now that number is in answer. So when I press equals, it will redo that calculation, but with 3,391 in. Okay. So I'm going to press equals, and this time I get 2,35856. Just to go to here, just to show you, if I take this thing one more iteration, there it is, 2,35856. And what it's done, it's taken the x value that we had, shot up to the curve, found the equation of the tangent, and worked out the x-intercept. And what it's going to do, it's going to converge and eventually find that point over there. Okay, so yeah. We're finding an x-intercept of a function, which we wouldn't otherwise be able to do. The way we're doing it is we're taking an initial guess, and we're seeing where the tangent to the curve hits the x-axis. And that is a better improvement, or a better approximation than the previous one. So if I just press equals now, guys, check. Equals, eventually it starts to settle. And in fact, it's actually kind of settled. It's not changing anymore. In other words, that's as accurate as this calculator can get that answer, right? If I go over here and I kind of carry on with my iterations here, and I say, right, there's 3, 4, these are actually exactly the same numbers that the calculator is getting. Notice it's actually settled as well, right, in terms of the sort of accuracy of this particular sketch. Yeah, I can't actually zoom in anymore, so it's, yeah. Okay, all right. So it's a seriously simple thing to do, and it's actually seriously clever as well, right? So what you would do, this question actually doesn't really give us any sort of specific detail about accuracy. Okay, let's just try another one. You guys try and do this one. Okay, now this is a normal. Yeah, let's do number 1. Okay, so you just go into your calculator. So this thing says to 3 decimal places. Okay, this particular question that we're doing now on page 5. I'm just going to write the formula down for you again, which you get given. Okay, so what, and you'll see the way we ask the questions at exams, we actually ask you to write down the specific formula you're going to use. So it's going to be xn plus 1. This is xn minus, now I'm going to put xn's in where all the x's are in my original function. This is just a quadratic equation, this one. And you wouldn't use the Newton-Raphson method for this, but 2xn minus 5. So this here is the specific one that's going to work for this, okay? Now what we're going to do is bring up our calculator. We're going to press 7 equals. And all that does, even if you press all clear, it puts 7 into the memory called answer. Then you type all this stuff in on the right-hand side here with answer. So when we press equals, the calculator is going to do the calculation with 7. All the xn's must be answers. Answer squared minus 5 lots of answer minus 3 over 2 lots of answer minus 5. And so you press equals and you get 52 over 9. Quite often the exam will ask you to show your first guess. So x naught equals 7, x1, I've got a brain like a 52 over 9. And the reason we do that, you guys probably know about the solve feature on these calculators. So we don't want you just to use the solve feature, we want you to actually use this method. Okay, but now you just press equals. Now this particular one says to 3 decimal places. So if you want to, you can actually see, well, when does the 4th decimal, in fact, almost immediately, guys, this thing says, yeah, so the final answer to 3 decimal places would be 5,541. Okay. Try number 2, yeah. Yeah, okay. So this here is just a name for a sequence. So basically we're generating a sequence of values. X naught is our first one, x1 is our second one, x2 would be our third one, etc., etc. And notice what this formula does. If you put an xn in, for example, x16, okay, what does it generate here? It generates x17. And if you put in x95, you get out x96. And then if you put x96 in, you get out x97. So you keep getting the next approximation. Okay. Just a really, really important thing, and it is written here as a sort of remember, this thing solves for kind of x-intercepts. So you can't, here your function is not x cubed, you've got to subtract 9 from both sides. So here we're trying to find x cubed equals 9, but we've got to get a 0 on the right-hand side. This here is our f of x, only when you've got a 0. Okay, so the particular formula here will be xn plus 1 equals xn minus, what am I going to put on top here? Yeah, so we say xn cubed minus 9, that's f of x, and what's the derivative of 3x n squared? Absolutely. Okay, now we slot, and the reason I'm showing you 500 is miles away from the cube root of 9, okay? Because cube root of 9 is obviously what we're finding here, right? So 500 is miles away, but I'm going to show you that it doesn't matter. Very quickly, this thing will get to the right answer. Okay, so I'm going to go 500 equals, and then I'm going to type in the right-hand side. Answer minus fraction, answer cubed, minus 9 over 3 lots of answer squared. Yeah, look, it takes a while, but I mean, it went from 500 to 333, okay, but I mean, it takes a while, but I mean, I think I had to press the equals button like 10 times, 12 times or something. Okay, and so I actually get 2,08008. Okay, in the exam we'll tell you how many decimals to give your final answer to. 2,08008. Okay, so that would be to 5 decimals. Okay, so it's actually very straightforward, all right, in terms of a kind of thing, all right? There are 2 things that I just need to tell you about. 2 things where, not that it can go wrong, but where something interesting can happen. Okay? So, look at this. Look at this one now, and I want you to try. I want you to try solving this equation. Okay, 2x cubed plus x squared minus 8x equals 4. And I want you to use a first approximation of 1. In other words, x naught is equal to 1. Okay, so again, I'll write down the formula. Xn plus 1 equals xn minus the function evaluated at xn over the derivative of the function evaluated at xn. Okay, just try and solve. So our actual function, remember you've got to have a 0. This is our actual f of x. Okay. Yeah, so what we're looking here is kind of, are there any issues with this technique? And there's meant to be an issue here, which I'm hoping you guys are going to find. Has anyone managed to do it yet? So there's your formula. It's quite a lot of typing into your calculator, but you're going to put 4 equals. So you're not going to put 4 equals. You put 1 equals, and then you're going to type all of that in, and then you're going to press equals. Okay, so you get a maths error. Okay, that's interesting. Okay, all right. So okay, and I'll tell you why. You get a maths error straight away. Okay, I'm going to show you why. I'm going to type this particular function in: 2x cubed x squared minus 8x minus 4. Sorry guys, give me 2x cubed plus x squared minus 8x minus 4. Okay, I'm going to take that back to 0. 2x cubed. Was it plus x squared?
Yes.
Minus 8x minus 4. Okay, there it is. Can anyone see what's happened? What's gone wrong? And remember what this thing does. Our first guess was 1.
What's it?
It's a turning point. So if you pick a turning point, it stuffs out, because what's the derivative of, what's the bottom of that fraction? 0. And that's why you're getting a maths error. So if you unluckily pick a turning point, Nansinkinga, we have a problem. Okay? I'm going to show you. It actually says infinity. All right? Because it shouldn't really say infinity, but it does say infinity. Can you fix it? How can you fix it? Just choose a slightly different starting point, and you'll see. You'll see if you choose a different starting point, all right, then we don't have the problem. Okay. So one of the roots to this thing is 2. Okay, and we can actually find it quite easily. Notice, your starting point actually. These tangents just kind of zoom in on the root. It's a kind of a beautiful piece of mathematics. But there's a problem, okay? There are potential problems, okay? And so the reason for this maths error was, we used the turning point. So I'm just going to show you 1, and is 0, 100%. We picked a turning point where f dashed of 1 equals 0, and that's why we got a maths error. Okay, because this piece over here was 0. Okay, but it's not a huge problem, but it's just something you ought to be aware of. Okay, I want you to try this one. Try solving this x cubed minus 2x plus 2 equals 0 with a first approximation of 1. So again, I'm going to write the formula down for you. Xn plus 1 equals xn minus the function evaluated at xn over the derivative of the function evaluated at xn. No problem. I am recording this, and I'm going to stop fairly soon as well. So, sure. Thanks for coming. Yeah, I'll just send it to you guys. Yeah. I don't think one's a turning point here. Yeah, it's close. It's quite close, but I don't think it is a turning point. So this one's going to be xn cubed minus 2xn plus 2, and the derivative is obviously 3xn squared minus 2xn. So what happens? You get? So x naught is 1. What's x1? You got 0, and x2? 1. It's yeah. So what it does is it cycles, okay? And I'm going to show you this one because it's actually quite cool. All right. What is it? It's x cubed. 2x squared, or just 2x, yeah, plus 2. Okay, and what we're trying to do, we're trying to find the x-intercept. Okay, I'm just going to zoom this thing slightly, all right? And if we go over here, there is an x-intercept, and notice I can find the x-intercept, okay? But if you happen to start at 1, okay, the tangent at 1 hits the x-axis at 0, and the tangent at 0 hits the x-axis at 1. So it just cycles. It goes into like an infinite loop, and it never converges to a solution. It's not a train smash, but it's just something we've got to be aware of that can happen. Okay? If we just choose a different starting point, we can find the x-intercept. And it's interesting that you'll see it kind of shoots off. Notice here, we're trying to find this point over here. Our first guess is not too bad. Our second guess is reasonable. Our third guess is actually awful, just because of the shape of the curve. But in fact, if we just kind of, if we just do that and that and that, eventually it actually kind of comes back, okay? And it finds the actual answer. Notice I'm making the answer more and more accurate. It's basically it's kind of zoomed right in there. Okay. The last thing before we stop is that depending on where you start, you might get different routes, okay? So look over here. My initial guess here was 1 on this parabola, and it honed in on this x-intercept. However, if I chose an initial guess of minus 2, it actually comes to that one. So if you've got a function that's got like multiple solutions, you might need to start in different points to get different solutions. Okay. The derivation is what I did in class earlier today with you guys. This is just a neat typed up version. You don't actually need to know how to derive it. You do need to know this formula. Okay. It gets given to you, so you don't need to know it, but you need to know how to use it. Okay. Guys, I think I'm going to stop there. I will share the recording with you guys, and you can decide whether you share